Sorry about the size of the font. I copied this from my math lab. The population of a city is 450,000 and is increasing at a rate of 3.5% each year. Approximately when will the population reach 900,000? Use a compound growth model. So compound growth, remember, is A equals P times 1 plus R to the T. In this particular situation, they have given us the P, the original population, and they have given us the R as a percent. Therefore, we can fill in P and R. The question that they are asking is, when will this situation reach 900,000? So in order to solve this, you should divide both sides by 450,000. Thus, you get this equation here. You would ln both sides. Therefore, the t can drop to the front. And you can divide both sides by ln of 1.035. You end up getting something like 20.1, but it's said to round up to the nearest integer. So make sure that you round up, so it was 21 years for this problem. Let's look at the next problem. The half-life of an element is about 19 days. There are 4.7 grams present initially. Express the amount of the element as a function of time. The formula you would use for half-life is A of t is equal to A sub 0 times 1/2 to the t over t half-life formula. So in other words, for this problem, the half-life, they told you, the time is 19 days. That's a given. They told you that A sub 0, the initial amount present, is 4.7 grams. So the function that they are looking for A is 4.7 times 1/2 to the t over 19. Now they ask, when will there be 1 gram remaining? So you go ahead and substitute 1 in here. And you're going to solve for t. So hopefully you can follow here the step-by-step work. So after dividing both sides by 4.7, we then can take this and ln both sides. And then the exponent can drop to the front. Divide both sides by ln of 1/2 and multiply both sides by 19. The next problem that we ran across said, use an exponential model and a graphing calculator to estimate the answer to the following problem. Determine how much time is required for an investment to double in value if interest is earned at a rate of 6.5% compounded annually. Let P be the starting amount, X be the number of years since the account was opened, and Y be the current value of the account. Write the equation that can be used to model the situation. So we need to remember that when they talk about something being compounded annually, we use this formula. So because they want the amount to double, basically your original P, we are calling still P. But we're looking for where is that going to double. So on the other side of the equals, we have 2P. And the rate 6.5% as a decimal, 0.065. You can divide both sides by P. We're assuming that P is not going to be 0 here, and you get 2. That allows you then to ln both sides. And when you ln both sides, the t can drop to the front. You can then divide both sides by ln of 1.065, and this will give you t equals 11.01. Let's look at the next example. If a colony of bacteria starts with 1 bacteria and doubles every 10 minutes, how many bacteria will the colony contain at the end of 48 hours? So I started off with this one kind of modeling for myself that at t is 0, we have 1 bacteria. At t is 10 minutes, we now have 2 bacteria. At t is 20 minutes, we now have 4 bacteria. T equals 30 minutes, 8, 40 minutes, 16, 50 minutes, 32, 60 minutes, so this is the end of 1 hour, 64. You may also notice that this is 2 to the 0, this is 2 to the first, this is 2 to the second, this is 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth. So 1 hour is made up of 6 intervals of time. They are asking about 48 hours. So you could set up a proportion where the 6 intervals in 1 hour would be similar to how many intervals in 48 hours. So the number of intervals would be 48 times 6. That is 288 increments of time in this particular case. Therefore, after 48 hours, the number of bacteria I would have would be 2 to the 288th power. They wanted you to write the answer as an exponential function, and so that would be exponential. Don't make the mistake I made, making it scientific notation, and then getting the answer wrong and getting frustrated. They wanted you to leave it in exponential notation.